Hello viewers, welcome to today's lecture on wireless local area networks. In the last two lectures, we shall discuss about two different types of LANs. In the first lecture on LAN, we discussed about the legacy LAN based on IEEE 802.80, 2.3, 4 and 5. And in the last lecture, we have discussed about the high speed LANs using token ring, that is FDDI, and also by using CSM and CD, particularly the fast Ethernet and gigabit Ethernet. Today we shall discuss about the wireless LANs, and here is the outline of the lecture. First we shall discuss why wireless LAN, and then consider some of the points dealing with limitation and challenges of wireless LAN. Then we shall consider two important standards. One is IEEE 802.11 standard and various aspects of this standard like transmission media, topology, medium access control, and also various extensions that have taken place we shall discuss. Then another very important technology, that is Bluetooth. Although it is not LAN, it is essentially used for private area network PAN, but it can be considered as part of this lecture, and we shall consider topology, transmission medium, and also medium access control technique used in Bluetooth. And on completion, the student will be able to explain the need for wireless LAN, and they will be able to identify the limitations and challenges of wireless LAN. They will be able to understand different aspects of IEEE 802.11 wireless LAN, particularly the transmission media, topology, medium access control, and security techniques used in this particular standard. They will be able to understand different aspects of Bluetooth, particularly the topology, transmission media, and medium access control. First, let us focus on why wireless LAN. In the last couple of years, the number of portable equipments have increased exponentially because of the advancement of VLSI technology and miniaturization possible. Now small sized battery operated computer, laptops, palm tops, cell phones, PDAs, all these are available. So these low cost portable equipments are essentially the driving force behind wireless LAN. Moreover, it offers many advantages. First of all, mobility. When a person is traveling, when a person is possibly taking food in a restaurant, when a person is attending conference or a meeting, even then even then he can communicate with the other computers, and so the mobility is the main feature of this wireless LAN. It allows mobility. People are on the move nowadays, and while moving, while going from one place to another, they can use the they can communicate with others. And also it has got other benefits, for example installation speed and simplicity, and wireless LAN can be installed in a matter of hours. On the other hand, wired LAN will take very long time to install. You have to do the wiring, cabling, and also the install equipments and various other things, and it is quite simple, as we shall see, simple to install and deploy. And as I mentioned, it offers installation flexibility. By installation flexibility, I mean very easily you can configure it in various ways. It can have different types of topology. You can reconfigure it, configure it, and reconfigure it in many ways. So it gives you very flexible way of deploying local area network. Then it has got reduced cost of ownership. initial cost of deploying wireless LAN may be little high, but in the long run, whenever particularly you are in a dynamic situation, you are moving from one office to another, you are expanding the business, in such situation it offers you reduced cost of ownership. Then as I mentioned, scalability is another important advantage. It can be very easily scaled. As the business, initially you can start with few computers, and as the business grows, or whenever the need for more and more computers and other equipment, they can be very easily connected to the LAN by using this wireless LAN technique. And you may be asking, if it has got so many advantages, why it was not so popular in the past? There are several reasons for that. First of all, earlier the cost was very high. Thanks to the advancement of VLSI technology, the cost is gradually decreasing based on Moore's law. You may have heard of it. The cost is decreasing at a fast rate, and as a result, this is one of the factors which is pushing wireless LAN technology. Of course, it has got another limitation. Even it is existing today, low data rate compared to the high speed of wired LAN. We have seen that now 10 gigabits per second is available, LANs are available. On the other hand, you will see the data rate for wireless LAN is limited to few megabits per second. So, it is only few megabits per second, but this few megabits per second may serve the purpose in many situations. Another important concern is occupational safety concerns. People are not very sure whether wireless LAN is damaging to health or not. Even that controversy is going on. For example, whether the cell phone should be used or cell phone has some effect on the health, this is not known. So, there was some concern, occupational safety concerns regarding the use of wireless LAN. So, there is a question mark, but people have started using it, and so far no ill effects have been reported. Another important limitation is licensing requirements. You know, whenever the transmission is done in a particular frequency, certain frequencies cannot be used. So, you have to take permission, you have to take license. So, there are this puts an restriction or a restriction on the use of different frequency bands, and as a result there is a constraint from the viewpoint of licensing requirements. So, these were the limitations. In spite of that, wireless LAN is gradually becoming popular, and although it has got some advantages and disadvantages, it offers a number of limitations and also a number of challenges. First one is low reliability due to susceptibility of radio transmission to noise and interference. You know, in case of wired LAN, this problem is much less, because you are sending through some kind of guided media. On the other hand, in case of wireless transmission, it is susceptible to radio transmission, to noise and interference. Other devices may be working in the same frequency band, so that will interfere with the signal. As a result, so there is some reliability concern regarding the susceptibility of radio transmission to noise and interference. Then fluctuation of strength of the received signal through multiple path causing fading. So, these signals can come through multiple paths, that leads to fading. It is a common phenomenon in TV. You must have seen ghost images and other things because of multiple path. That problem arises in wireless LAN. And another problem is due to security. So, it is vulnerable to eavesdropping, leading to security concern. So, whenever somebody is transmitting some signal in wireless media, obviously it is some kind of broadcasting. Anybody can intercept that and make improper use of it. So, eavesdropping is a concern. Finally, limited data rate because of the use of spared spectrum transmission techniques enforced to the ISM band users. As we shall see, one important technique, that is spared spectrum, is used in case of wireless LAN, and this leads to smaller data rate compared to wired LAN data rates. So, these are the limitations and challenges ahead of wireless LAN, and let us see how some of these limitations and challenges are overcome. First, we shall focus on one important standard, that is IEEE 802.11, that is as you can see, the most popular standard is IEEE the 802.11b, which is in use nowadays, commonly used nowadays, and like any other LAN technology, it uses two layers, physical layer and data link layer, and data link layer again has got two sub layers. One is medium access control layer and logical link control layer, and which is common to any other LAN. So, essentially these two, medium access control layer and physical layer, will be different, and other part will be same, like the upper layers can be TCP IP and other thing, which we shall discuss later. And as we have already mentioned, there are three important parameters that characterize a LAN: the transmission media, topology, and medium access control techniques. So, we shall focus on these three aspects of the two wireless LANs that we shall discuss in this lecture. First is the transmission media. The as I mentioned, the 802.11, in fact any wireless LAN technique uses sped spectrum technique. So, sped spectrum radio in 2.4 gigahertz ISM band, that is 2400 to 248 3.5 megahertz. This is the ISM band. Industry that ISM band is very popular, which is used by most of the household equipments. And what is the typical characteristic of sped spectrum? In sped spectrum, as you can see, there are two popular approaches using frequency hopping. This is frequency hopping sped spectrum, and another is direct sequence sped spectrum. So, direct sequence sped spectrum. So, in both the cases, what is being done, the frequency spectrum is spread over a wider range. For example, if the initial frequency spectrum is like this, and it is after that sped spectrum technique, it is spread over a much higher frequency band, and it has got several advantages. Number one is the power density. It gets spread over a much wider frequency band. So, this has got many advantages. So, whenever it is concentrated on a small frequency band, it adversely affects other equipments, other wireless equipments. So, this is being overcome, and also this allows some kind of redundancy. So, there are two aspects. One is lower power density over a small, for example, in this frequency band, as you can see, power density is lower compared to this one, and redundancy. These are the two important benefits of this sped spectrum technique. And in case of frequency, although these two approaches, frequency hopping and direct sequence sped spectrum, they use two radically different approaches. For example, in case of frequency hopping sped spectrum technique, the frequency it uses 79 non-overlapping 1 megahertz channels to transmit 1 megabits per second data signal. So, this frequency hopping technique is somewhat like this. Suppose you have to transmit some FM radio signal. What can be done? A small part of the music can be sent using one carrier frequency, next part can be sent by using another carrier frequency, next part by using another carrier frequency, and so on. So, if the receiver also has to keep on changing the carrier frequency if it wants to listen, otherwise it will not be able to listen. So, it has got two benefits. Number one is, as I said, that power density becomes smaller or for a small over a small spectrum frequency band. Another advantage is that if it provides you higher security. That means the users who are not having this and this is known. So, if it tunes to a particular frequency, it will simply hear some noise. So, it will not, they will not be able to receive the music. And so, this is the first approach. So, the frequency keeps on changing, the carrier frequency keeps on changing, and it sends 79 such frequency channels for sending the signal. And then using direct sequence spectrum, it in particularly in case of 802.11, it uses a simple 11 chip Barker sequence. This is the Barker sequence with QPSK or BPSK modulation. That means first some kind of modulo 2 addition is performed. For example, using this sequence, this is the +1 corresponds to +1 -1, some kind of modulo 2 addition is performed with 0 or 1, and then then this QPSK or BPSK modulation is performed before transmission. And third approach, which is based on infrared signal in the near visible range of 850 or 950 nanometer. This is also used, but not that popular. So, we shall mainly focus on the direct spread spectrum techniques, which is commonly used. So, this is the basic schematic diagram of the transmitter and receiver used in frequency hopping spread spectrum technique. As you can see, there is a pseudo random sequence generator which can select one of the 79 frequency channels. So, you have got 79 frequency channels. So, this code, pseudo random code, will select one of the channel, and with the help of the frequency synthesizer, that carrier frequency is generated, and that is being multiplied. As you can see, modulator FSK BPSK, that data comes and that is multiplied, and it is passed through a band pass filter and it is transmitted. So, here you get the spread spectrum signal. At the other end, the signal is received, and by using the same pseudo random binary sequence generator, it generates the sequence in the same order as it is done in the transmitter. Then the carrier frequency generated by with the help of the sequence synthesizer and channel table, and it is being multiplied with the received signal, and then it passes through the band pass filter. Then finally, it is demodulated, that whether if it was FSK or BPSK, and by performing demodulation we get the digital data. So, this is how the frequency hopping spread spectrum operates. On the other hand, in case of direct sequence spread spectrum, it uses 11 chip Barker sequence, and as you can see, this is the Barker sequence, and when a +1 is sent, this simply a 1 is converted into a sequence of 11 chips. So, it is 11 chips. So, instead of a single simple 1, that 11 chips, this is the signal which is being sent, and similarly for a 0, it is a 11 chip sequence which is just opposite bit by bit, that is being transmitted. So, this is the transmission of 1, and this is the transmission of -1, transmission of +1. So, +1 is essentially 1 and -1, as you know, is 0. This is used for pedagogical purposes. So, using this 11 chip sequence, the transmitter and receiver schematic is shown here. This is the carrier oscillator, that pseudo random sequence generator, which essentially generates that Barker sequence, which is multiplied, and then the data comes, and it is modeled that by BPSK modulation is performed, and then this is being modulated and sent. That spread spectrum signal is transmitted. At the other end, it is received, and using the same sequence, the multiplication is done. Then the demodulated signal, after demodulation, you get back the output data. So, you see, this is how the direct sequence spread spectrum occurs. So, this is the transmission media. Let us look at the topology. 802.11 standard supports formation of two distinct types of BSS. basic service set. BSS stands for the basic service set. The first type of basic service set is the ad hoc network, in which, as you can see, you have got 4 mobile stations. They can directly communicate with each other and form some kind of network. Second type of basic service set is known as infrastructure basic service set, and this one is having a special type of device which is known as access point. So, here you can see there is an access point, and with the communication, all the communication is done through the access point. Now, this access point can be connected to a distribution system. This distribution system can be, say, Ethernet LAN. There is no restriction, Ethernet LAN. So, this can be a Ethernet LAN. So, on this Ethernet LAN, these access points are connected. So, you can see here, this is a basic service set, this is another basic service set, this is another basic service set. So, the mobile stations can move from one basic service set to another basic service set, and also the access points can communicate with each other through this distribution system. And in this, the advantage is the mobile stations can also communicate with stationary stations. For example, the systems which are connected to the Ethernet LAN, which is connected to the distribution system, can communicate with any one of these basic service set. However, here the communication is little difficult. Apart from the address of the mobile station, the destination access point, source access point are to be incorporated. So, some kind of 4 addresses will be involved, as we shall see. So, this is known as extended service set, which requires more than one access points. This is the basic topology used in 802.11. Now, you may be asking how stations select their access points. We have seen in the previous case, say you have under this basic service set, you have got several mobile stations. Under this also there are several stations. These access points are somewhat similar to base stations used in cellular network. Later on we shall discuss about it in details. Nowadays cellular telephone is very popular and people are familiar with base stations. These access points are somewhat similar to base stations for these mobile hosts or stations. Now, as you can see, this particular mobile host can move gradually from this basic service set to other basic service set. So, how they get attached to a particular access point, this is being explained here. This can be done in 2 ways. One is known as active scanning, when a station joins a network or when it wants to discontinue association with the existing access point. What it does, it sends a probe frame and all access points within the reach reply with a probe response frame, and the station selects one of the access points and sends the AP an association request frame, and the AP replies with a association response frame. So, these are the frame exchanges takes place, and with the help by doing that, a particular mobile host gets associated with a particular access point. Second approach is passive scanning, where access points send beacon frames periodically and stations may respond with association request frame to join an access point. So, in this particular case, a particular access point can advertise that, hey, is anybody there to join me. So, in that way it sends this association access frame. So, it sends the beacon frames and then association request frames are generated by the mobile host to join a particular access point. So, this is how it takes place, and once the stations join a access point, the communication is done through that access point. Now, as I mentioned, the medium access control in wireless LAN has got several challenges, particularly it is prone to more interference and it is less reliable compared to wired LAN, and the wireless LAN is susceptible to unwanted interception leading to security problems. How these are overcome we shall discuss. Moreover, there are so called hidden station and exposed station problems which I have discussed in detail while discussing that CDMA CA protocol. And in fact, this 802.1 uses little extended form of CDMA, this is not carrier sense multiple access collision avoidance protocol, CSMA-CA protocol, and here the sender sends a short frame called request to send which is of 20 bytes to the destination. Request to send also contains the length of the data frame. So, destination station responds with a short cleared to send frame, and after receiving that cleared to send frame, the sender starts sending the data frame. As of course, in this case collision can still occur as I have explained in detail, and in such a case cleared to send frames is not received with a certain period of time, and that it has to come out from collision by using that binary exponential backup algorithm used in the case of wired LAN in Ethernet. That is why this approach is also known as Ethernet wireless Ethernet LAN. So, although I mean there are many similarities with Ethernet. Now, apart from similarities, there are some dissimilarities. One is carrier sensing. In case of wired LAN or Ethernet, the carrier sensing is very easy. All stations are attached to the medium. So, from that the carrier sensing can be done. In this particular case, carrier sensing is done in two ways. One is known as physical carrier sensing, another is virtual carrier sensing. So, in case of physical carrier sensing, physical carrier sensing is performed at the radio frequency radio interface by analyzing the detected packets and strength of the signal. That means, all the mobile stations will be receiving signals generated by other stations within that basic service set, and the signals will be analyzed at the radio interface, and after performing it will analyze analyze the detected packets and comparing the strength of the signals. Obviously, whenever there is collision, strength of the signal will be more. So, this is one way of detecting collision. Another alternative or identity for carrier sensing or detecting collision, another alternative is virtual carrier sensing is performed by the source station by informing the length of the data it intends to send to the stations within the basic service set. So, this is actually related to this protocol. Here, as you have seen, whenever this request to send frame is sent, as part of that the length of data is also mentioned. That means, whenever this cleared to send is signal is generated, all the stations will withdraw except the station except the destination station, and all other stations know the length of the data. Obviously, for that duration all the stations will not generate any data. So, this is how these are the two approaches used for carrier sensing. This is virtual. So, without actually sensing the carrier sensing is performed, because everybody knows a particular station will send for a specific period of time based on the data rate and length of frame. Now, coming to the security, wireless LANs are subject to possible breaches from unwanted monitoring, because as we have seen in case of wireless LAN, all the other stations within the range will be able to hear. So, how to overcome this problem? So, to overcome this problem, IEEE 802.11 specifies an optional MAC layer security system known as wired equivalent privacy. Basic idea is that it should have the privacy level or security level same as the wired LAN. So, to do that, what is being done? It is done with the help of a 40-bit shared key authentication service. Later on, we shall discuss about it in more detail. This approach, this 40-bit shared key authentication service, and by default, each basic service set supports up to 4 40-bit keys that are shared by all the clients in the basic service set. It provides privacy, but no integrity check. Now, there is some extended version of the standard advanced encrypted standard AES that is being proposed in this standard H0 2.11i. This is the revision for authentication and encryption as a long term solution. So, by using AES, authentication and encryption can be used as a long term solution. Obviously, in this particular case there will be some overhead for encryption and decryption, but it will give you security as well as authentication. Now, here are the IEEE 802.11 frames. As we know, there are three basic operations to be performed by these frames. First of all, the management frames. Management frames are used for station association, deassociation of the with the access points, timing and synchronization, authentication and the authentications. I have already explained the protocols in brief, and obviously with the help of the management frames these functions are performed. On the other hand, this is required in the initial phase when a particular station gets associated with an access point. Then control frames are used for handshaking and positive acknowledgement during data exchange. We have seen that CSMA, carrier sense multiple access CA protocol uses a 4-way handshaking approach. So, this handshaking and positive acknowledgement during data exchanges, this is the part, this is performed with the help of these control frames. Finally, data frames are used for transmission of data. So, there are three different types of frames possible in IEEE 802.11, and you see these frame control bits decides the various types of control frames. Then MAC header provides information on the control frame and duration, addressing and sequence control. I am not going to explain the details of each of them because it will take quite some time. So, you can read it from any textbook, you can get the details, but this is the this is in brief what is being performed by the various data packets, various frames used in IEEE 802.11. Now, as I mentioned, the 802.11 has been extended in various directions. It was established in June 1997, which specifies 2.4 gigahertz ISM band and frequency of 1 megabits per second or 2 megabits per second data rate, and it was extended to IEEE 802.11b in 1999, having the following key features. It is backward compatible with 802.11. It uses the same 2.4 ISM band. Then it supports new data rates of 5.5 megabits per second and 11 megabits per second by using special coding, and particularly two coding techniques are used. The mandatory coding mode known as complementary coding keying CCK modulation and packet binary convolution coding. So, we are skipping the details of these coding techniques. However, with the help of these codings, these higher data rates are possible, 5.5 megabits per second and 11 megabits per second using the same ISM band. And it is very popular, it is popular because of backward compatibility with the original standard IEEE 802.11. Now, subsequently IEEE 802.11a has been proposed, which is successor of 802.11b. It uses unlicensed 5 gigahertz band, and it uses a special type of coding known as orthogonal frequency division multi-carrier coding. It is essentially very similar to frequency division multiplexing, but there are some differences. We are not discussing the details here, and it supports a variety of data rates starting from 6 megabits per second to 54 megabits per second, 6, 12, 24, 34 and 54 megabits per second. And for 54 megabits per second, the typical range is small to 20 to 30 meters. For lower rates, the range is 100 meters or more. Then another standard IEEE 802.11g, actually it is compatible with IEEE 802.11b. This one is not. IEEE 802.11a is not compatible with IEEE 802.11b. So, this success of IEEE 802.11b has led to another extension that provides 22 megabits per second transmission. It retains the backward compatibility with the popular 802.11b standard. So, here are the various extensions shown here: 802.11, which uses frequency hopping spread spectrum, and direct sequence spectrum 802.11a, which uses OFDM, then IEEE 802.11b, which uses direct sequence spectrum, and 802.11g, which again uses OFDM technique. Now, we move on to another important standard, which is Bluetooth. This Bluetooth is used, has been developed for personal area networking, particularly used for design to connect computers, cameras, printers, and various household equipments which are used in house. So, this is essentially used as a private area network, typically to be used in a house. Nowadays, the number of intelligent equipments are increasing in a house, which can be networked with the help of this personal area network. And it is an ad hoc type network operable over a small area such as a room, and it is based on IEEE 802.15 standard. So, you can see that Bluetooth actually conforms to IEEE 802.11 standard, IEEE standard. Now, here is the Bluetooth topology. It supports two types of topology. First one is piconet, second one is scatternet. So, a piconet is a very small ad hoc network with only 8 stations. As you can see, it has got a master and other such slaves. So, you can have one master and 7 slaves. Of course, apart from 7 slaves, one slave can be kept as standby, or it is can be kept which is known as parked state. However, if this particular slave wants to join, then one of the active slave has to be taken out, and it supports all slave stations synchronizes their clocks with the master. That means, all the communication is performed with the help of the master, through the master, and possible communication can be one to one or one to many. So, there are two possibilities, and there may be a one station in the park state, as I mentioned. So, that can join only when one of the active slave is taken out. Then the second topology that is being used is scatternet. It makes, as you can say, one slave as a master of another piconet. So, here as you can see, this is one piconet, and this is the master, and this is one of the slaves, and this slave is now made master of another piconet. So, here you have got 8 stations, out of which this is one slave, and this slave now becomes a master of another piconet. So, in this way you can have scatternet, and number of such mobile stations can be more than 8. So, scatternet is formed by combining several piconets, as it is shown in this diagram. Now, let us look at the transmission media. The transmission media is same as that is being used here is 2.4 gigahertz ISM band. That means, it uses the same frequency band that is used in IEEE 802.11. So, it uses the same band. So, there is a possibility of interference. So, if you are using Bluetooth and IEEE 802.11 network in the same region, there is possibility of interference because of the use of same frequency bands. And as you can see here also, it uses 79 channels, each of 1 megahertz, and it uses frequency hopping spread spectrum method, as I explained in case of 802.11, and it hops 1600 times per second. So, a frequency is used for 625 microseconds only, and it uses a sophisticated version of frequency shift keying called GPSK for modulation. So, the carrier frequencies can be say starting with 2400 megahertz or 2.402 gigahertz to, you can say, add 1, add 2 and so on. So, 2.2402 plus 78, that means it can go up to 2480 megahertz. So, as I mentioned, there is a possibility of interference with the IEEE 802.11b because they uses the same transmission media. And so far as the medium access control is concerned, it uses a special form of TDMA called TDD TMDA. So, this is essentially some kind of duplex medium, half duplex communication. As we shall see, it performs some kind of half duplex communication using this TDD TDMA approach, and communication for each direction uses different hops, different frequencies. And so, one slave, one master, the possible alternatives are one slave, one master, and slave. So, in case whenever there is one slave, one master communication, then master uses even slots and slave uses odd number slots, as we shall see. And this process is more complex when there are more than one slave. Let us see how it is actually being done. As you can see here, this is the master, this is the dwell time. So, this is the dwell time. Dwell time is 625 microsecond, out of which 366 micro is used for sending data, remaining is used for hop control. So, it uses a frequency of carrier frequency of F0 and in the slot T0, you can say. This is the even number of slot. Then the slave sends in slot number T1, odd number slot, uses frequency F1. So, it uses hops, the frequency hopping is taking place. Then again master sends in slot T2 using frequency F2, and we have already seen the various frequencies that can be used. So, in this way, in a alternately master slave. So, it is some kind of half duplex communication take place between the master and slave using frequency hopping, and the frequencies that is being used is as I have shown, these are the frequencies. F0 is 2402 megahertz, F1 is 2403 megahertz, and so on. On the other hand, here as I mentioned, this is single slave communication. When you have got multiple slaves, then the process is little complex. First, the master initiates the communication, it sends a frame using frequency F0 in slot say T0. Then essentially it selects, it is some kind of select and polling approach. So, the station which is being selected or polled responds in the next slot T1 and uses frequency F1 and it sends the data. So, if it has got, then in the next sequence again the master sends using in slot T2 even number of slots and uses a frequency F2, and now it can select another slave, and then the slave 2 can respond and it sends in using frequency F3 in slot T3. So, in this way several slaves can communicate and they are being selected or polled by the master stations. Here also half duplex communication take place. However, the even frequencies are being shared by different slaves to send their data one after another. So, so far as the Bluetooth frame format is concerned, there are 3 types: 1 slot, 3 slot and 5 slot. In case of 1 slot, it can send 366 bits plus 259 is used for that time is used for hopping and control, as I have shown in this case. So, this time is used for sending data, and this part is used for hopping and control. So, as a consequence, a total of 366 bits can be sent in 625 microsecond. On the other hand, when it is a 3 slot frame, then it can, then as you can see, it is divided into two parts. This hopping and control, that time is fixed. However, within this time, after subtracting this much time, the total number of bits that can be sent is shown here in 3 slot frame. On the other hand, in 5 slot frame, the total time you get is 5 into 625 microsecond, and within this time, so you can send 2866 bits plus 259 microsecond for hopping and control that is being used. So, you can see the frames can be quite short, comprising 1 slot, 3 slot or 5 slots. So, any one of the frame formats can be used. And here is the detailed frame format shown here. So, you can see the access code has got 72 bits. So, it contains synchronization bits, identifiers of the master and so on using these 72 bits. Then it has got a header of 54 bits. So, the header is 54 bits. So, this 54 bit header, here the 18 bit is repeated 3 times. So, in this 18 bit you have got 3 bits for address, then 4 bits for type of data that is being sent. Then as you can see, there are 3 bits, one is flow control, acknowledgement and sequence number. So, you can see here with the help of this approach, one can do the Bluetooth performs flow control, error control and also the acknowledgement by using stop and wait control technique. And there is a 8 bit checksum that is used for error detection in the header field. So, as you can see, all the features required for reliable communication is provided in this simple frame format. Now comes the data field. In this data field, as you can see, the number of bits can vary from 240 to 2740. So, this is the for n is equal to 240 in 1 slot frame, n is equal to 1490 for 2 slot frame and n is equal to 2740 for 3 slot frame. So, this is the frame format used in Bluetooth. Now, coming to the applications of wireless LAN. Wireless LANs can be used in variety of ways. One is LAN extensions. We have already discussed the wired LANs and different type of wired LANs, the legacy LANs based on IEEE 802 and also the high speed LANs based on FDDI, Fast Ethernet or Gigabit Ethernet. Now, they can be extended. For example, here a simple example is shown. Here for example, this is one LAN, wired LAN, this is another wired LAN. So, 2 wired LANs, and suppose this is in one building and this is in another building. So, you have these two are located in 2 separate buildings and in between you have got some kind of road. Obviously, it is not possible, it is I will not say not possible, but it is very difficult to dig through the road and set up wired connection. Instead of that, one can set up 2 wireless LAN bridges on the rooftop, and the 2 LANs can be linked with the help of this wireless LAN. So, in this way the communication between 2 LANs can be established with the help of wireless LAN bridge. So, you can see here we have used for LAN extension of wired LANs. Now, wireless LAN can be used in buildings having large open floor. Suppose in an auditorium which has a large open floor, it is not possible to set up wired LANs interconnections. So, one access point can be set up, can be put in the somewhere, and then all the mobile stations can communicate, and particularly in auditorium in other places this is very suitable. This wireless LANs can be used very easily. Then in small offices, when you have got a very small office, then it is not really necessary to have elaborate wired LAN. you can have one small an access point, and then several desktops or even laptops having wireless LAN interface can be interfaced, and that way it is very flexible to have a small office using wireless LAN. Then another important application of wireless LAN is in historical buildings. So, you have got some historical buildings which cannot be tampered. You cannot really deploy wired LAN by putting a wire. You cannot really dig, you cannot make hole in the wall, you cannot dig, you cannot do anything of that kind. So, in such a situation, like museum and other historical buildings, you can set up wireless LAN very easily and perform communication. Then since the deployment type of wireless LAN is very small, it can be used in rescue operation site. Suppose there is a flood, there is earthquake and this kind of disaster. In such a situation, you can very quickly set up a wireless LAN and establish communication, and then communication with one another. So, these are the possible applications of wireless LAN. Obviously, I have given a very small number of applications. The application domain is increasing with time and it is possibly limited only by the imagination. Now, here is the trend. I have mentioned about the trend of wireless LAN. Although initially wireless LANs were perceived to be a substitute of wired LANs, now it is recognized as an indispensable adjunct to wired LANs. That means, when the wireless LAN was announced, people thought that wireless LAN will gradually replace the wired LANs, but this has not happened because of the limitations, particularly lower data rate and other limitations. But now what is being considered? Wireless LAN is being considered as an adjunct to wired LANs. So, both of them will coexist and both of them will interoperate, and this way they will work with each other. And a hierarchy of complementary wireless standards which are designed to complement each other has been established by IEEE. So, a hierarchy of various wireless standards have been developed which will help in the proliferation of wireless LANs. So, the proliferation of wireless LANs is driving the demand for broadband connectivity back to the internet. So, this is essentially a wireless metropolitan area network standard, and this can fulfill this limitation, and last mile broadband wireless access can help to accelerate the deployment of 802.11 hotspots and home and small office wireless LANs. Nowadays, in many public places like airports, hospitals, this kind of hotspots are being deployed where wireless LAN access points are available with which the mobile users can communicate. And as I mentioned, the hierarchy of standards for private area network, local area network, metropolitan area network and wide area network, IEEE has a series of standards like IEEE Bluetooth, which is 802.15, then 802.11 LAN, 802.16 metropolitan area network, then IEEE 802.20 that is being proposed for wide area network. So, a number of complementary wireless standards are being developed to meet the goal anywhere, anytime. You will be able to communicate from anywhere at any point of time. Now, this is time for giving you review questions. First question is, widespread spectrum technology is used in wireless LAN. Second question is, how hidden station problem is overcome. Third question is, what is network allocation vector. Fourth question is, what is WEP, wired equivalent privacy, and how is it achieved? Distinguish between piconet and scatternet used in Bluetooth technology. So, these are the 5 questions, and here are the answer to the 5 questions given in the last lecture. First question was, how FDDI offers higher reliability than token ring protocol. As I mentioned, this dual counter ring topology that is being provided provides you higher reliability, and we have demonstrated if a particular link is disconnected or a station gets disconnected, then a secondary ring is used to reconfigure the topology, and with the help of that communication is done by wrapping up the primary ring with the secondary ring. This is how the higher reliability is achieved. Second question was distinguish between a switch and a hub. As I mentioned, a hub is essentially a multi-port repeater and it works in as a level 1 relay. On the other hand, a switch is a fast bridge working in layer 2. So, on receiving a frame on one port, it forwards it to a particular port, contrary to the hub which sends to all other port based on a this. So, here it is sent to a particular port based on a table inside the switch after checking the integrity. The switch in general operates in the data link layer or layer to layer, as I mentioned. Third question was why 4B by 5B encoding is used in fast Ethernet instead of Manchester encoding. As I mentioned, this is being used to reduce the baud rate. So, essentially, if Manchester encoding was used, then it will require 200 megabaud, but by using 4B by 5B, it is possible to use only 125 megabaud and to achieve the data rate of 100 megabits per second. So, this reduces the cost of implementation. Fourth question was what is carrier extension, why is it used in gigabit Ethernet. As I mentioned, for detection of collision a minimum size of frame is required. However, as the speed is increased, that size has to be increased, but instead of increasing the frame size, carrier extension is being performed up to 512 bytes, so that the collision can be detected in gigabit Ethernet. So, essentially carrier extension is being done for collision detection. The last question was why flow control is performed in gigabit Ethernet network. How flow control is performed in gigabit Ethernet network. As I mentioned, the full duplex mode of communication is exploited in gigabit Ethernet network to implement X on X off protocol, which is somewhat similar to stop and wait protocol. So, you have got two stations and you have got full duplex communication. So, if one station is sending at a fast rate using the other link, it can the station, the receiver can request to send at a lower rate or stop sending until it is ready. So, this gigabit Ethernet uses this X on X off protocol. So, friends, with this we conclude our lecture on LAN technology. We have discussed three different types of LANs: legacy LANs, fast LANs, high speed LANs, and finally in this lecture we have considered wireless LANs. And in the next two lectures we shall consider other techniques, other approaches, other uses of medium access control techniques. Thank you.